This seminar is part of a set of activities carried out by the National Institute of Statistics and Geography, INEGI, to continuously contribute to the development of the skills of the statistical and geographical community, as well as the analysis of topics and trends that affect our work. Data visualization is a valuable tool to help us better understand the complexity and relationships of phenomena that are hidden from view. It allows access more information, generate new questions, and communicate messages efficiently and effectively. In the age of data, it is important to democratize access to information and knowledge, and proper visualization results is an excellent link between subject matter experts and society. Data visualization is a process in which various disciplines intervene: artistic, technological, analytical, and specific themes. We hope that this seminar will help us better understand each of these phases and develop our skills. I would like to welcome Professor IMIRIAH MEYER and thank you for giving this conference. Visualization is a very important and broad field, especially for an institution like INEGI, with its coverage of many topics: geography, environment, socio-demographic, governmental, and economic. Communicating the information we generate as accurate as possible to offer different audiences is a challenge for us in INEGI. But visualization can also be a powerful analytical tool to obtain more information data. This is our motivation to join forces with CIMAT to organize this seminar, where different possibilities of data visualization will be presented. Just to close my intervention, I would like to thank CIMAT and particular Professors Victor Rivero and Johan van Hoorbeek for their support and collaboration in the organization of this seminar. Thank you. The floor is yours, Victor.
Thank you very much, Sergio. Good morning, everyone. It's a pleasure for us to be here, to be the host of this series of talks. And I will actually, in fact, switch to Spanish, and I apologize for that. I actually prepared my short speech in Spanish, but I will kind of translate what Sergio was saying. Es realmente un honor para nosotros poder ser organizadores, coorganizadores de este ciclo de conferencias y charlas sobre visualización de datos, teniendo como público objetivo al público en general, pero especialmente al personal que trabaja en el INEGI, ¿no? Generando información, generando elementos para la toma de decisiones. Es un ciclo de conferencias que se realiza a partir de hoy y hasta el mes de octubre con talleres y demás. Esto es otro fruto de una larga colaboración que hemos tenido con el INEGI y que ha dado lugar a diversos resultados interesantes como maestrías en especialización en estadística y cómputo para los tomadores de decisiones. Decía Sergio hace rato la importancia de la visualización de datos, cómo es relevante en todas partes. Yo diría que hoy en día estamos en uno de los momentos más importantes para las matemáticas, ya que generamos muchos datos, pero necesitamos que esos datos se vuelvan información. Información que sea valiosa para la toma de decisiones, para poder llegar a conclusiones. Digo yo que los datos es muy diferente de la información y la información la podemos plasmar, la podemos visualizar gracias a estas herramientas tan potentes que se han desarrollado en la visualización de datos, que nos permiten entonces entender las conclusiones de los fenómenos que estamos entendiendo, especialmente geográficos, sociales, políticos y demás. La línea de ciencia de datos es una línea estratégica para CIMAT, en la cual se han impulsado diversas actividades, ya que ahí hay mucho desarrollo matemático por hacer para implementar nuevas herramientas, nuevos elementos para entender, para manejar estas enormes, grandes bases de datos. Y bueno, quiero también agradecer a quienes han impulsado esto desde el INEGI, ¿no? Su director Julio Santaella, con Sergio Carrera, por supuesto, y muchas otras personas que han apoyado, como Gerardo Leiva, Enrique de Alba, Vicky Abrín, que han estado en todo momento impulsando, fortaleciendo la colaboración que tenemos entre el CIMAT y el INEGI, ¿no? Y por supuesto, no quisiera yo dejar de mencionar a toda la gente que en CIMAT ha estado involucrado, está interesada en estas actividades, en particular en este momento a Johan, a Rogelio, a Claudia, a Ivette, con un apoyo de personal técnico muy importante que permite que todas estas actividades trascendentes, no solo para el CIMAT, sino para el INEGI y la comunidad en general de tomadores de decisiones, estén al acceso y tengan los desarrollos digamos, más fuertes y en la frontera del conocimiento. Entonces, bueno, con esto termino, ¿no? Y agradezco la invitación y deseo que tengan un excelente evento, que disfrutemos todos de todas estas charlas. Muchas gracias y buenos días. Adelante.
Muchas gracias, doctor Sergio, doctor Víctor. Ahora tomo el micrófono instantáneamente. Muchas gracias a todos y a todos por acompañarnos a este evento. I'm going to switch to English. Thanks for joining us. It's really a pleasure to have with us Professor Meyer to start off this seminar series. So just let me give a brief bio from Professor Meyer. She is an associate professor in the School of Computing at the University of Utah. She co-directs the Visualization Design Lab, which focuses on the design of a visualization system for helping people make sense of complex data. She obtained her bachelor's degree in astronomy and astrophysics at Penn State University and earned a PhD in computer science from the University of Utah. Prior to joining the faculty at Utah, Meyeriah was a postdoctoral research fellow at Harvard University and a visiting scientist at the Broad Institute of MIT and Harvard. So it's a really pleasure to have with us Professor Meyer. So, antes de comenzar, un breve anuncio. Por favor, para las preguntas, les pido que las envíen directamente a dos coanfitriones, Amado o Alejandro, que estarán en la parte superior de la lista del chat. Y por favor, redactar sus preguntas en inglés. So, before we start, just let me give you an announcement. For the Q&A section, please use the chat box and send a direct message either to Amado or Alejandro. You should see them at the top of the list of the chat box. So without further ado, the mic is all yours, Meyeriah. Thank you so much.
Great. Good morning, everyone. Thank you so much. Thanks for this invitation. Thanks for showing up. And also, I just want to let you know, I very much appreciate everyone being willing to speak in English today. I am really excited to get to be here this morning and to talk a little bit about the research that we do in my lab. I'm going to, for the next 30 minutes or so, walk you through a series of projects that we've worked on in order to illustrate the kind of impact in the world that visualization research of the kind that we do in my lab that we have. So thanks again. And as you heard in the introduction, I'm a professor at University of Utah in the School of Computing. And for those of you who have never had the opportunity to be in Salt Lake City, it is a really, really beautiful place. As you can see from here, this is actually a photo of the campus of the University of Utah with the beautiful Wasatch Mountains in the background. And today is my first day back in my office on campus post-pandemic. So this is all just very exciting for me. So bear with my overexuberance. So here at the University of Utah, I get to work with an amazing group of researchers in the Visualization Design Lab, which is a group that I co-direct with my colleague, Alex Lex. And so we're a group of about 15 students, postdocs, and faculty members. And really the sort of guiding theme in all the research we do in the Viz Design Lab is very applied visualization research. And so what I mean by that is that we spend a lot of time actually doing the practice of visualization design, collaborating with people in a variety of fields. So the kinds of tools that we're producing span, a big gamut of aesthetics and capabilities. And so in developing these tools, we really use these projects where we're working with people in the world as a test bed for us to ask the kinds of deeper research questions that we have around the process of designing visualizations for people in the world. In my group, we work with people in a really broad range of areas. Done a lot of work with people, with analysts in biology, from systems biology to computational biology. Also had a whole thread of projects in the last few years on urban air quality. This is also a picture of the beautiful Salt Lake City Valley. Not so pretty sometimes in the wintertime. Because of the topology, we get a lot of these winter inversions and can have some of the worst pollution in the US at times. And so this has been a really exciting set of projects because it's built on citizen science and engaging with community members to look at how we might better help people understand real-time air quality estimates. I've also had some projects in the space of public health, which, right now, we're all very tuned in to public health and the importance of it. And I'll talk about one project in that space later. But my work has also spanned the gamut all the way over to digital humanities, where I've had the opportunity to work with poetry scholars and thinking about what does it mean to visualize poetry. And so it's really getting to work with amazing people across so many interesting fields that is sort of the thing that drives me in the work I do. A little more specifically about actually how we do our research. In our group, we really rely on a visualization methodology that we call design study. And so design study is a type of inquiry within the visualization research community. And at a very high level, a design study is a project where we go and analyze a real world problem. So this requires working with real people, with real data on real problems. We then, based upon what we learn from working with our collaborators, we design visualization systems to help them make sense of the data that they're struggling to understand. We deploy these tools back into the hands of our collaborators and validate the designs that we have in the wild by trying to see how they use the tools, what's easy, what's not, what they're learning from them. And then at the end, we spend a lot of time sort of reflecting and discussing the kinds of things that we as designers and researchers have learned along the way in order to develop guidelines, lessons learned, new techniques, ideas that we basically then feed back to the research community. And so this mode of research inquiry we developed about 10 years ago, and since then there's been a lot of work in the community looking at theoretical underpinnings. This isn't just about going off and talking to people and building a tool. We have a lot now of theory around how to do this in a rigorous and structured way. And what I wanted to focus on this talk is giving you a flavor of in this kind of very applied visualization research, what's the spectrum of things that we learn about? How do we have impact in the world through this? And so at the sort of, I think often the most obvious way that we have impact is about creating tools for people who are trying to analyze data and helping them do that. And so I'm not going to actually talk about that kind of impact here because I think that's the really obvious one. What I want to talk about is all the other stuff that as a visualization designer, you can learn through the act of working with others. And I'm going to give examples of that. And it's going to be three core themes. And the first one is learning about visualization design, new techniques and things like that. The second one is visualization design, where design is a process. Like, how do we actually go and do visualization design in a way that is effective? And then finally, the thing that I've gotten super excited about in the last couple of years is really how we use visualization as a probe into how people think about data. And so I sort of view this visualization sometimes very much as the human side of data science, and what we can learn about data and analysis and stuff through giving people tools and watching them. So this is what we're going to talk about for the next little bit. And so let's dive in. So visualization designs. You know, when we think about this, you know, often a very common visualization research contribution that comes out of design study or this kind of research are new and innovative ways for visualizing data. And the design of these new techniques is grounded in the specific needs of our collaborators, but we really look at these techniques and how they might generalize to a broader class of problems. So for example, we had a project a number of years ago where we designed this new technique called a curve map for some systems biologists. And it's really, it allowed them to look at related time series data ordered in certain ways based upon phylogenetic trees. But this technique generalizes to many other problems where you're also trying to look at a lot of time series data based upon other attributes of the data set as well. Another technique that we designed was something called the connectivity matrix, and we designed this, in fact, for some neuroscientists that we're working with here at the at Utah. And this technique is really about, it's a play on adjacency matrices, which is another way of looking at graphs and networks. But here, instead of looking at single connections between any two nodes, you're looking at patterns of paths, patterns of types of connections between them. And so this, even though we designed this for neuroscientists, this really generalizes to many problems where people are looking at complex graphs. And then another example was just this, in this poetry project I had, we really thought a lot about, like, what does it mean to even datafy a poem? And here we were focusing on sound. And so we had a lot of interesting techniques that came out for how we represent a poem sonically using a variety of natural language processing techniques, and then how we might look at that data in a spatially constrained space. In this case, the space happened to be the space of a poem. So these were all novel techniques that came out of design studies that we did. But what I wanted to tell you a story about was also how we can use these real world problems as a way to really probe and question existing visualization sort of dogma and representations. And so here I'm going to talk about a project that was led by one of my students, Sam Quinnen. And we were working with some local wildfire forecasters here in the Salt Lake Valley. And so these wildfire forecasters, like all wildfire forecasters across the West here, they're all trained meteorologists. And so what they do is they are looking at weather predictions and trying to understand what they think is coming up during wildfire season, combining that with information that they have about the burn rates and sort of dryness conditions in order to advise wildfire managers where to be careful, where they might want to send resources, where they might want to hold it back, and et cetera. And so when we started talking with our collaborators, they sort of explained how they felt like they had a fire hose of data coming at them, and the existing sort of traditional meteorological tools that they were using to visualize their data were causing them, as they said, to do mental gymnastics. So we went in, and the first thing that we do, which is typical in these kinds of projects, is we spend a lot of time interviewing our collaborators. We go to their workplaces and observe their work patterns, and we attended daily briefings in order to understand their workflows and to really try to get at what are the challenges that they're encountering with their data. So we also, to augment that observational work, we also can we spent a lot of time collecting a set of visualizations that our collaborators were using on a daily basis. Here I'm showing you just a couple of what those look like, and they really, they're standard sorts of meteorological visualizations that thousands of meteorologists around the world use every day. They're very standardized and they're very static. And so we looked across these images, and what we did is we tagged them by what data they showed and how that data was visually encoded. And so then from these data sources, both the observations, interviews, and our coding scheme, Sam designed a new tool that provided our collaborators with views that used interactivity to try to reduce some of the visual clutter. We also introduced some new techniques for visualizing uncertainty. The visual conventions in this tool pulled from the standard views that our collaborators have been using, but we sort of tweaked them in order to nudge the views towards some guiding visualization and design principles. And so after this project, at the end of this project, we spent a little bit of time reflecting on our design process. And one of the things that struck us was the prolific use of views by these meteorologists that violated what we thought were fundamental visualization design principles. So in particular, our collaborators, and again, thousands of other trained meteorologists around the world, use views that discretize continuous data fields such as temperature and pressure. And this idea of discretizing data that's inherently continuous goes against a principle that we have called the Expressiveness Principle, which is that the visualization should show all of the data and only the data. And so by using these discrete color maps, they're sort of losing information because the data is getting binned. And so the other thing we noticed was that meteorologists make extensive use of rainbow color maps, which those of you who are maybe embedded more deeply into the Viz community, visualization people love to hate on the rainbow color map. So we were really interested by these places where the practice of these professionals was not aligned with the principles that we hold near and dear as visualization designers. And so we used this as an opportunity to sort of probe into this. And, I think one view could be, well, those silly meteorologists, they just don't know good visualization design. But a different approach that we decided to take was like, wow, all these thousands of professionals are using these types of techniques. Maybe there's something to them that we don't really understand yet. And so we teamed up with some cognitive scientists on campus to run some controlled studies. And we first were really interested in this idea of the discretization of continuous data fields. And what, if any benefit that might give people in making judgments on data. And so we designed this controlled lab experiment where we gave our participants increasingly discretized data views. You can sort of see on the left-hand side here, we had like a perfectly continuous data view, and on the right, a very discretized view. And we ran our participants through 12 different tasks that were based upon the kinds of things we saw our meteorology collaborators doing. And interestingly, what we found was there was not a single task where the continuous did better than the discrete. And there was a number of tasks where people performed better using these discrete color maps. And so that was really interesting to us because it says that there are some benefits to using discrete color maps that might warrant actually not showing people all the data at once. We also then did a follow-up study looking at the notion of rainbow color maps because one of the things that always strikes me about them is they seem to discretize data, like perceptually discretize it. And so after having found benefits of discretization, we then went and did a study with rainbow color maps to see, do they in fact discretize the perceptual space? And we found that they do. And so there's some interesting work, I think, yet to be done here to try to unpack, are people using rainbow color maps because they get these perceptual benefits? And so they may not be as terrible as we think that they are. And so these were examples of projects that we did by finding interesting questions that we could probe more deeply as researchers based upon the things that we saw people doing in the real world. And so those are just some examples of the kinds of ways that we can make an impact in visualization research through the process of designing tools for others. So the next thing I want to talk about is impact for the visualization design process. And I'm going to start with I'm going to start with a little scenario that sort of lays out what I feel like most projects that I work on, how they start. So let's say, we're going to have a conversation between a biologist on the left and a visualization designer on the right. And the first thing we might ask is, what do you want to visualize? And the kind of response we might get is, well, from patterns of conservation, we want to visualize the mechanisms that influence gene regulation. And to a viz design researcher like myself, it kind of sounds like this. And, I sort of use the slide as sort of, a joke, which I'll tell you on Zoom, I'm just going to imagine everyone's laughing right now. But the reality is this is what projects really start like for us. And so I'm, as a researcher, that one of the things I'm deeply interested in is how we go from an initial, scenario and not understanding of an application space to a set of design requirements that lets us build an effective tool like this one. And the ways that we do that in our group is we very much embed ourselves in we try to embed ourselves as much as we can in the ways that our collaborators think about their data. And in fact, many of my students do field studies where they'll spend 3 or 6 months sitting in the labs of people that we're working with, attending meetings and getting to know people to really understand the kinds of challenges people face with making sense of their data. And so a side effect of this is trying to understand how we can do that process effectively. And so here I'm going to tell you about another story. And this was a project that we did with some neuroscientists here at the University of Utah who study connectomics. And this was a project that was led by another student of mine, Ethan Kersner. And so these neuroscientists, what they're studying is they're trying to, the big goal is to try to reconstruct the wiring diagram of the brain. And these neuroscientists do some pretty crazy science where they take little cubes, in this case of our collaborators, of rabbit brain, and they slice it very thinly, and then they use a very high power microscope to take pictures. So then they end up with this cube of data for which they can go in and segment and actually reconstruct which neurons are connected to which neurons and so on. And so at the end, what they get is a very large, dense network of connections. And so when Ethan started working with this group, he was doing all the traditional kinds of interview and observation work that we were always doing. But he was getting very frustrated because he'd go and talk to one lab member. They'd say, this is the most important thing we need help with. He'd go and talk to another lab member and they'd say, no, this is the most important thing. So after months of this, he really was like, I'm getting nowhere. I don't understand what the best opportunity is for us. We need to do something different. And so about that time, in our reading group for our research lab, we were reading a paper from a group out of London. And in this paper, they conducted a design study, but they were working with energy analysts. And one of the things that they did in this paper was to use what they called creativity workshops. So putting their collaborators through workshops that were meant to inspire creativity. And in the paper, this group that was based in London described a whole bunch of different design requirements that they were able to understand through these workshops. Which they ultimately turned into a successful visualization tool for the group. But most compelling to us when we read this paper is that these workshops took a fraction of the time to get to design requirements than more traditional interview and observation methods take. And so Ethan decided to try this. And so he designed and ran a creativity workshop with our neuroscience collaborators. And it was a complete success. He was able to uncover a broad range of visualization needs from the group in just a single day, as well as to build trust and credibility and agency with these scientists. So from this, Ethan designed and deployed a visualization tool for exploring patterns of different paths in the networks that were in these neuroscience graphs. which the scientists are still using today to understand how different types of neurons interact to transmit messages in the brain. So after he had this experience, he approached the lead author from that energy analyst paper, Sarah Goodwin, at a conference in order to just talk about their experience of running these workshops. And these initial conversations led to a 2.5-year collaboration among the group in London and the group here at Utah, where we collectively reflected on our experiences of running 17 workshops in 10 projects and on 3 different continents. And the result of this was a formalized description of these creativity workshops for visualization design that was grounded both in our experiences of running these workshops, as well as in some of the theories, the psychological theories behind group creativity. The description of these workshops outlines the considerations for designing and conducting creativity workshops, along with a set of brainstorming activities that we've been using repeatedly with success. And these workshops now are they're just a core method in our research group, and we run them in almost every single project that we conduct. And I speculate that for each project, they save us months of time that we otherwise would be spent doing some traditional interviews and observations. So they're wildly successful. A couple of years ago, I had an opportunity while I was on sabbatical in Vienna, Austria, to work with a PhD student there, Christian Knoll, in doing some experiments and running these workshops in a more diverse set of contexts. And so we ran them at the University of Vienna with university administrators, at the United Nations in Vienna with people who study drug trafficking, at the Austrian Academy of Sciences with some historians, and in Paris with some digital humanists. And we learned a bunch of new things about these workshops, what makes them work and what doesn't. One of the really interesting things we learned was the role of native language that it plays in fostering collegiality and agency. Our initial work had only been with English-speaking groups, and so it was really interesting to see what happens when you put together people who speak different native languages and the effect that has on people's ability and willingness to brainstorm together. So a lot of interesting things came out of this follow-up work. So this was an example of how we use this visualization design process as a way for us to dig deeper into learning how we can do what we do more effectively. Okay, so the last thing that I wanted to talk to you about was this idea of how visualization is a probe into helping us learn more about data science. And I talked to you about this with a project in global health. And this was a project led by another student of mine, Nina McCurdy. And here we were specifically working with public health experts who were studying the spread of Zika in Latin America a number of years ago, and specifically with a focus on some of the really tragic side effects like microcephaly in babies who are infected in utero. And so, this project began when Nina went to Washington, D.C. to work at the USAID in a 6-month field study where these public health experts were. And when she started, this project had like all the signs of a really straightforward visualization design project. The experts had data. They had already tried to incorporate standard visualization techniques into their workflows, and they weren't working. And they were really excited to work with us on some new innovative ideas. They were really adamant about their need and desire to take a more data-driven approach to their analysis. And so we were super excited to dig in. During the field study, Nina developed and deployed a prototype to explore the Zika data that these collaborators had, along with augmented it with data about in-country programs that international organizations had in place to combat the disease. And ultimately, the goal of the tool was to help these global health experts make decisions about whether or not to move or expand various programs based upon their projected status of the outbreak. So Nina built this tool you're seeing here, which uses sort of best practices of how we combine data and make use of interactivity and multiple linked views. And when she evaluated this tool at the end of her field study with multiple different stakeholders, the feedback was really positive, indicating that the design she had created was a really effective representation of the data. But we noticed a hesitation by our primary collaborators to actually embrace the new tool for their own analysis. And so as we started to probe the reluctance, we were able to confirm that even though the tool was a good reflection of the Zika outbreak data, the data itself was not an accurate reflection of what the experts knew to be true about the outbreak in the region. And so a hint of this first came up in a discussion that Nina had using a choropleth like this one that showed Zika data at the case Zika case data at the national level. So for example, here we're seeing Brazil in dark red, which indicates a relatively high percentage of cases in the population, whereas Colombia is in a lighter orange, which indicates a lower percentage. And so when we were discussing these maps with one of our collaborators, she noted that, oh, while Brazil reports all cases, Colombia runs a full investigation before making any reports. And the implication of her comment was that there's a difference in how these countries report Zika cases that was resulting in aggregated data that presents an inaccurate and possibly misleading picture of the situation. And I have to say that throughout this pandemic, we've seen the same thing over and over and over again, that when we try to aggregate data, we're losing a lot of the details that actually are really a rich and important way to understand, for example, how, what's going on with COVID. So there were so many similarities that I saw personally in the way that we were thinking about reporting COVID to what we saw in the Zika case. So what we ended up doing in this project, though, is we pivoted to focus on this problem of these data discrepancies and found that the data was littered with these discrepancies. And but that the experts we were working with had a really deep and intimate knowledge about the errors and where they stemmed from. So in the case of the Zika data, the discrepancies really came from the way that the data was being processed, reported, and collected in different ways. And this distributed heterogeneous data generation pipeline was implemented in a different way in every country. And this leaves the data set with subtle variations of how the underlying data was generated and processed, the vast majority of which was not documented in the data. And so and each country's data generation pipeline was shaped by its local political, cultural, economic, geographic, and demographic context. And it was resulting in discrepancies like the union in region X goes on strike often and doesn't report Zika data. Or country Y recently overhauled its surveillance system, leading to a sudden increase in detected cases. So from here, we developed a sort of a theoretical way to think about this called implicit error, which we define to be measurement error that is inherent to a given data set, assumed to be present and prevalent, but is not explicitly defined or accounted for. And so we developed a characterizing description of the implicit error and also an annotation mechanism to support externalizing implicit error for our Zika collaborators. So Nina extended her original visualization tool to include the annotation mechanism to support our collaborators in externalizing what they knew about the Zika spread. This allowed them to share their knowledge with their colleagues and to augment the data with this contextual knowledge that they have. And so, as I mentioned, although this work was grounded in a project with Zika experts, I think it's, outside of even public health, this notion of data discrepancies comes up all the time in many fields. And so this project, though, for me, what was super interesting about it, like when I step back, is that it wasn't just about annotations and errors and discrepancies. It was actually a lens into a more fundamental issue that that data science really is only just beginning to acknowledge. And this problem stems from the fact that data is not neutral, and neither are the algorithms we developed to process it, or the systems we're building to store it, or the interfaces we designed to visualize this data. All of these technologies are emerging from many decisions, some of which are made by developers and some of which are made from systems of convention, culture, history, and power. And that visualizations, though, can help people in reasoning about data, including about what the data can and cannot tell us about the world. And as visualization practitioners, I think it's really important that we don't forget that the things that we make are also impacting the conclusions that people come to. But at the end of the day, I think that insights really come from experience and knowledge. Insights and impact come from people and not from patterns in the data. And so in my research, I've been thinking a lot about what visualizations can reveal to us about data and how it's impacting the world. And these ideas inevitably touch on issues of inclusion and exclusion, the design conventions that we lean on, and the structures of power that ultimately impact how we decide what is a good visualization versus a bad one. And so that was just a sort of a quick dip into the ways that I think visualizations, visualization design, and visualization research can really add a new lens on data science and thinking about how we are using data to make really important decisions today. Okay, so that's what I was going to present today. Just giving you again a sort of glimpse of when we do applied work, which is about designing tools for people in the world. What are all the different kinds of things we can learn about and the ways we can have impact in the world beyond giving people a nice new tool? We can learn about new visualization designs, as well as learn more about things that are things that we think are tried and true. We can learn more about the visualization design process and new ways to do it. And then also, again, using visualizations to probe into people's relationship with data. So with that, I just want to say thank you so much for being here and giving me this opportunity to share my research with you. Here's my contact information. I will mention that later this summer, I'm going to be moving to a new university over in Sweden. So if in the fall you're trying to find me for any reason, I'll be on the other side of the Atlantic. So thanks again, and I'm happy to answer any questions you guys might have.
Thank you so much, Mariah. And just for the record, I was laughing at the blah, blah, blah joke. It was a really
Thank you for saying that. Thank you for saying that.
It was an insightful talk, and really, it's really interesting, all the research you have done and the knowledge you have collected. So we will start the Q&A section, and Amado will help me with that. And let me ask you the first one. So when we talk about visualization, it's not just about making a chart. It's a whole process where the relationship between the topic expert and the visualization expert is crucial. And you made it very clear in your talk. So from your experiences on the various collaboration and research you have made with people from different disciplines, what are the main breaking points, either for good or bad, to end up with an engaging and useful visualization output?
Yeah, it's a really interesting question. I have to say that the sort of short answer to that is I think a lot of what I see is if people don't spend enough time trying to understand what the problem is. In our own experience, usually when we start working with some new collaborators, they're, it's often people who've been struggling with their data and trying visualizations. So they're like, oh, if only I could just make this thing interactive or just put these two pieces of data together, then I'll be able to answer this question I have. And so that's usually the first thing we do, is the thing that our collaborators think they need. And once we do this thing that they think they need, suddenly they're like, oh my goodness, that's so interesting. Actually, this is the thing I really needed to do. And so visualizations, we find in almost every project we have, is that once you get an initial, visualization into the hands of people, the thing they thought was the problem totally changes. And that's where it becomes, as you were sort of saying, it comes this sort of symbiotic relationship where, as a viz person, you're impacting your collaborators, and then your collaborators, are giving you new opportunities to do new things. And so visualization, it's not just these like two, there's the viz people and the collaborators. You really become these like partners who are, working towards a bigger goal of, whatever field it is that people work in. And so I feel like a big missed opportunity is if people stop at that first initial idea and don't continue to go on. And so like in our group, we spend a lot of time trying to think about ways to do rapid prototyping. Like what's the quickest way we can get these initial ideas out, whether it's like paper prototyping, even just like, using a lot of standard tools like MATLAB or Tableau, because we find that those initial ideas are usually not the most interesting ones. So sort of it's a long process. I find it very rewarding, but stopping too soon, I think, is a really huge pitfall.
Okay, thank you so much. Amado, please. You are.
Yeah, I'm sorry, I was muted. Yeah, I have a question for you. It's how do you choose, or what do you consider when choosing the projects you're going to work in among different fields? I mean, among health, applied sciences, social sciences, environment, and so on. What are you looking for when choosing a new project? Do you see, are you looking for a challenging project? You consider how diverse it could be, what could you learn from it, the impact it could have. What are you looking for in a project that you're going to work in, besides what are they looking for, the people that you're going to collaborate with?
Yes, to all those things you suggested. Those are all important things. I'd have to say that, like, really it's about people. And so like I'm in such a privileged position where I have more people that approach me to work on projects than we have time for. So we do get to really pick. And honestly, the most important thing is probably like, is this someone that I want to spend the next 2 years with, like talking to? Are we going to laugh? Are we going to like have a good time? Do they respect the kind of work that we want to do? Are we going to have the opportunity to sort of mutually pursue, perhaps very disparate goals? Those are honestly the things that drive something more than anything. I will, over the years, when I first started doing this kind of work, I was, for a number of years, I was really only working with biologists, and it's an exceedingly interesting field. But when I came to Utah as a faculty member, I started getting approached by a sort of more diverse group of domain experts. And I really came to appreciate how people trained in different sort of schools of thought, how they think about data so differently, and how much I've learned about the design process. Like, for example, I went from working with biologists to working with poets, and I would like use all these methods that worked to collaborate with biologists, and then it like wasn't working with the poets. Go figure, they think differently about data and about like technology. And so I've really come to appreciate how much I learn by working with people who think about the world so differently. And so I think going forward, absolutely, like people who are working in fields that I've never like gotten a chance to work in is like a really like exciting thing for me. But as a researcher, the sort of the two important things is this someone I can work with for a long time? And is this someone who understands that I'm not just, our group, we're not just software engineers who are just going to build some sort of interactive tool, that we do have a research agenda. And while we want to support them, we also need them to support us. So those are probably the most important things.
Absolutely. Yeah. Thank you very much. I don't know if we have time for another question.
Yes, we do. So
okay.
Let me take one, please. In the CCAP tool, could you comment on how the annotation were used by the expert involved? Did you end up using the paradata in any way to visualize the biases in the data?
Great question. I'm going to have a really unsatisfying answer. So we really got this insight about these data discrepancies pretty late in the project. And Nina built the annotation mechanisms and stuff after she had already left DC and was back here in Utah. And so she did deploy this to a few people in the group, but honestly, there was a lot of political stuff going on, and the groups were changing, and frankly, our collaborators were leery to use it because there was all this stuff about not so much concern about the knowledge that they have about countries and about responses, that they were honestly like scared to have it get out beyond like trusted colleagues and stuff. So there was all these things that came up for us around what happens when people share deep and intimate knowledge. How do you allow people to share it with some people but not others? So it basically opened up more questions than it answered for us. And so we had hoped, and Nina did some initial design work on how we might actually visualize these annotations back in the tool. But because we hit a wall and lost our collaborators with the change of administrations, I'm sure people can understand what I'm talking about, that we weren't able to pursue that. But I actually have a student right now where we're looking at this notion of implicit error in a very different way, actually from a feminist theory perspective, something that we're calling entangled insight. So really trying to have a more authentic view of how insight comes to be from like someone who's sitting down and doing visual data analysis. This idea that it's not just there's a pattern in the data and that's like, the data is speaking. Insight comes from, an expert bringing all the knowledge that they have to the things that they see and the things they've seen before, and maybe something else going on, a conversation they had with their group. And so we're trying to think about what's a sort of more authentic way to describe how insight comes to be. And it's really this entanglement of tools and people and history. And I think annotation is just one way that we might help people expose more of that insight process. We have another project here doing something called data hunches. So a lot of times we find that collaborators, they're like, well, really the data is a little bit higher here because like the instrument, this instrument wasn't as good, or like COVID cases weren't really being recorded accurately for whatever reason. And so this idea that people have hunches about the data. And so right now we have a project exploring how might we what are sort of visual techniques to help people express those data hunches. And then when you have a bunch, how do you visualize them back? So it's like this huge interesting space that this Zika work just started initially helping us understand. Sorry, that was a long roundabout question, and the answer is no, they didn't really use the annotation, unfortunately, but there's a whole lot of interesting stuff that it exposed to us as researchers.
Thank you. Amado, please.
Yeah, I think we have time for one last question, maybe. It's a question in the chat from David. He says, what programming language are better for this field, thinking of R versus Python maybe? And is there any additional tools that are highly recommended for going into this kind of endeavor, thinking of coding in Java or D3 maybe?
Yeah, so I'd have to say we use all those tools in our group, and so my poor students, like they come in and they have to learn like a huge toolbox of different techniques. Things like R and Python we find are really great for a lot of the early stage prototyping and work, and just when we need to get into the data. But ultimately, like all the tools that I showed are D3 tools. So when we actually think about building a more complex system that we want to deploy to people, visualization design has really moved to the web, like so many other things for data analysis. And so we largely, once we're at the point where we're creating a more sophisticated, multiple linked view interactive tool, we largely use D3 and the sort of JavaScript landscape. And wow, that landscape is changing all the time, and that's so frustrating. And you always have to learn some sort of new technique, or it's new tool, and that's the unfortunate answer. But otherwise, I mean, Python, R, like whatever it takes for you to quickly be able to mock up stuff, like that's all part of our sort of rapid prototyping toolbox.
Thank you very much.
Thank you.
I think Alejandro has the last question.
Well, we have some minutes left. So this is from Irving. How do you measure visualization effectiveness?
Oh my gosh, that is such a an important question and so hard to answer, and I could just talk forever. It's really hard. It's really hard. You know, in the Viz research community, there's this whole very established side of research now where people are doing a lot of these cognitive science types of experiments, but it's more sort of basic research, like how do people perceive things? What kind of cognitive like things are happening when you look at a chart? And I think when you're building the kinds of tools that I showed here, where they're complex, they're interactive, and these tools are not used in isolation, they're used as part of like a larger analysis workflow. I don't want to say impossible to evaluate because, of course, in theory, anything's possible. But largely, I don't think it's worth our time trying to evaluate in some sort of quantitative way. Like, what does it mean for, you know, a lot of the tools we design, there is no A/B comparison because the tool before didn't exist. So I find it to be just a sort of fruitless exercise to evaluate quantitatively. And so what we do is we do a lot more qualitative kind of work. So a sort of standard approach for understanding is this tool meeting goals is to do case studies where we deploy the tools again into the hands of our collaborators, let them use it, and sort of develop a qualitative case study around how they were used, what sort of impacts did it have, and so on. But even that, to me, like most of the stuff that I talked about in this talk, like it didn't even have to do with the tool. It was more about the kinds of things that we learn or observe as design researchers in the process. And that's even harder because it could be, these creativity workshops. Like we had, all these researchers doing all these different projects over years and years. How do you, and we learn from that, but how do you evaluate that knowledge? And so a lot of this is about deep thinking. It's about having a lot of discussions with people. So this notion of critical reflection, where you're bouncing ideas off of, you're developing themes, you test it out against your experience and others until you feel like you get to a pretty solid bit of useful knowledge that fits in with your own experiences. And that's largely how we evaluate these sort of non-technique tool-centric kinds of ideas. I will say we have a thread of research around this right now because when you have a messy design process that lasts 2 years and you end up with like, oh, these workshops are great, how do you transparently report on how you got to that insight? And how do you, and so I have a PhD student whose whole dissertation is around this idea of how do we trace the evolution of insights and contributions, what are the kinds of artifacts we need to be recording throughout these processes? How do we then report using those artifacts? There's a whole bunch, I think, of super interesting stuff going on in that space. But at the end of the day, when it's about a lot of deep thinking based upon your experience and stuff, there's a lot of interesting work yet to be done about how do we as researchers help others evaluate that process we went through to ensure that it's credible, that it's plausible, that it makes sense. So yeah, I guess that's kind of no clear answer. Just controlled studies, I just think for this kind of work are just, I don't know, they don't really tell us much.
So
they make us feel good because there's like a number, we like numbers, but I don't think at the end of the day they tell us much about the effectiveness of what we're doing.
We have a couple of minutes left. Just let me ask you the last one. For discretization of the color maps, what method do you use for discretized data? Do you use the adaptive or unsupervised algorithm?
Yeah, it's an interesting question. So for that project, we just created bins, like the values between here and here are this color and so on. And so it was just these linear bins. But there's a lot of interesting stuff that could be done as far as like both database, like looking at the data. And there's been work that's been done in some of the scientific visualization literature, looking at like volumetric data, like how do you find useful boundaries by looking at the distribution of values. And I think that you could do that for the color maps as well. But also yet a different dimension of that, which is actually what we build in a lot of our tools, is giving users the ability to sort of control, like interactively, like build your own color map, like, little handles to say, oh, I think it's going to be around here. And to me, that's really compelling because what I actually see people doing is it's a form of data exploration just to like make your own color maps. Like when you're moving sliders and stuff and you're seeing how that changes the data, that in and of itself is a kind of data exploration. So in that specific study, we were just doing these linear bins, but yeah, you could totally apply some sort of, algorithms that are looking at distributions of data sort of in the data space. But I think there's really compelling things to do also in the sort of people space and giving people the techniques to make these sorts of boundary decisions themselves too.
Excellent. Well, unfortunately, we ran out of time. So let me thank you once again. And we hope to have you soon in Mexico.
Oh my gosh, I would love that. Please invite me again after the pandemic.
So before we end, just let me give you an announcement in Spanish. Los invitamos a consultar la página del INEGI sobre este seminario de visualización que estaría posteada en el chat para que ustedes puedan conocer los siguientes expositores. Entonces, les agradecemos mucho. Thank you so much. And we will see you soon. Thank you so much.
Thanks, everyone.